Border gateway protocol, very important protocol. Where do we use? We use it in the WAN phasing, wide area network. Okay, so all so far we were dealing with the LAN protocols, LAN routing protocols like RIP, EIGRP, OSPF. Now we are talking about EGP, or exterior gateway protocol. Okay, so let me draw an example. So let's say I have two routers on my core. The core routers are connected to distributions, and these distributions are connected to the access layers. Okay, and these access layers are connected to multiple computers. Now these core routers are connected to ISPs. Okay, so far the protocols that we were discussing like OSPF, EIGRP, RIP, they are part of LAN routing protocol. Okay, now let's say a user who is browsing Google, or who is browsing Facebook, so his packet from his machine will hit the access layer switches. It will be sent to the core layer devices, the distribution layer devices, and from there it will take towards core, and then it will move towards internet, and from internet it will start switching, it starts routing from one ISP to other ISPs. Okay, and finally they reach the destination Google server. So over here, over on the WAN segment, we make use of protocol BGP to route the packet, whereas in the within the LAN segment we had OSPF, EIGRP, RIP, which were forwarding the packet. Now why can't we make use of BGP as a LAN protocol? The reason is BGP is slower. It's very slower. Okay, whereas these protocols are very faster. What about the routing that they support? So let's say I have one LAN unit which is connected to ISPs. Okay, these ISPs would have connected with multiple LAN, different companies, right? There would be multiple companies, a multiple LAN segment which is connected to ISP. So obviously the ISPs are going to have high number of routes when compared to individual LAN segment. So I can say that BGP can handle more number of routes when compared to your LAN protocols like OSPF or EIGRP. BGP can accumulate more number of prefix or networks. If you talk about the two protocols, okay, BGP are slower but they are reliable. Okay, so let's say if a LAN segment is sending a packet over onto first ISP, now ISP will send to second and third and so on. Now if BGP wasn't reliable, not reliable, so what would happen? Gradually this LAN segment or the users within the LAN segment would lose the connectivity, or they would see the intermediate issues. What are intermediate issues? Like slowness or packet drops, right? Because if this protocol is not reliable, okay, if is not able to deliver the packet to the destination, so you cannot trust those ISPs. So what makes BGP reliable? BGP runs on TCP protocol, transmission control protocol, and TCP works on three-way handshake. Okay, and due to these three-way handshake, this whole protocol is slower when compared with OSPF, EIGRP, RIP. They do not have any uh, mechanism for reliability, or they are not meant for having three-way handshake or reliable sources. Okay, they have a factor called reconvergence. If one route goes down, the second comes up. But in the case of BGP, it's not about reconvergence. If one goes down, might be there is only one path to reach the destination. Okay, so you cannot trust on the reconvergence, but you can, yes, trust on the reliability. If you're sending a packet, let's say you sent a packet from ISP1 to ISP2 and then ISP2 to ISP3, but your packets are all getting dropped. Let's just assume an example. If BGP wasn't reliable, now your whole packet is getting dropped. So how would these users reach towards Google, right? So the inbuilt feature of BGP is to support reliability, not for faster packet routing, or neither it's for reconvergence. Okay, it's for reliable communication from one end to another end. So let's see point to point, so it will be much more easier. So if you see from my slide, this is the RFC, okay, 1654, over which the BGP was initially standardized. It's called as EGP. EGP stands for Exterior Gateway Protocol. Okay, external facing protocol. It's a vector routing protocol. Okay, we are going to define the neighbors. Let's say in the case of OSPF and EIGRP, how do we make neighborship? We just configure, or we just bring the router OSPF process on all of them. They will automatically send the hello packet. They will check for the components if they are matching, and then they automatically form the neighborship. But in the case of BGP, there is nothing called automatic. Okay, if I have two routers, let's say this is dot 1 and this is dot 2, I have to manually define that this is my neighbor, dot 2 is going to be my neighbor, and over on dot 2 I have to manually define dot 1 is going to be my neighbor. Okay, so I'm going to define my vector. It's a path vector protocol, and it provides scalability, flexibility, and network stability. Network stability, flexibility, scalability, it's all in the ISP that we see. Okay, we need stability in the network. If BGP is not able to provide stability, so what is going to happen? So basically different companies are gonna uh, lose the connection, right? They are the multiple LAN segment or multiple startup companies who are connected to let's say ISP XYZ, and if ISP XYZ is not stable, so basically they will have the intermediate or the fluctuation happening, right? So the work of ISP from point of the protocol is to provide scalability, flexibility, and stability in the network. It's not about fastness. Okay, it's not about reconvergence. It's about scalability, flexibility, and stability. So when BGP was initially created, it was focused on IPv4 for inter-organization on public network. So let's say if I have two LAN segment, let's say this is a branch office and I have another branch office. So how do I connect them? So with the help of the BGP protocol. So let's say I have one instance of BGP running here and I have other instance of BGP here. So basically the BGP was initially created to focus on IPv4 because IPv6 was later on released, but IPv4 was launched in 1980s. So this protocol was focused to connect to LAN segment over on internet. So this is only the protocol that runs over on ISP, Internet Service Provider, which is having close to 7,80,000 of routing routes. Okay, so why so many number of routes? Because all of us are connected over internet or ISP, right? So any application, or if you talk about any companies or organization, all our networks or all our packets at the end goes towards ISP, and from between the ISPs or between one LAN to another LAN, it's your BGP. So BGP has around 7 lakhs 80,000 of IPv4 routes, and it's still growing. So due to the large number of routes inside BGP, or the BGP is meant to handle large number of routes, they do not advertise the incremental updates, okay, or they do not send the refresh network advertisement like how we see in case of OSPF or ISIS, which is a ISP protocol. Okay, so main component of ISIS is Lisp, whereas in OSPF we call it as LSA. Okay, they are almost same. OSPF is enterprise protocol, whereas ISIS is your ISP protocol. So the working behavior of BGP versus OSPF is different. The packets, the incremental updates are not seen in case of BGP packets or BGP tables. Okay. Okay. So there are some key points here which you can refer during any interviews or for your own knowledge. So let me quickly cover up them. So BGP stands for Border Gateway Protocol. It's a dynamic routing protocol. Okay. So there are two types of protocol. One is called as static. The other one is called dynamic. Okay. So dynamic has the two types now. It's interior gateway protocol and exterior gateway protocol. IGP has three flavors. We can call it as RIP, EIGRP, and OSPF. Whereas EGP has only one flavor, which is called as BGP, and that's what we are now. Okay, so we are going through BGP, so that's why it's actually one of the dynamic routing protocol. Yes, it's also called as EGP. BGP is the only EGP that we use. BGP is also called as protocol of the internet. As we discussed, there's only one protocol that's supported in the ISP. So all your internet routes, multiple networks, everything are dependent on BGP now these days. Okay, this is a application protocol. Why we call BGP as application layer protocol? So let's say when I have RIP, OSPF, EIGRP, we call it as network layer protocols, or we call it as a layer 3 protocol. But when we have BGP, we cannot justify them that it's a layer 3 protocol, because BGP internally work on TCP. So I can also say that it's a part of layer 4. Now, who works on TCP or who is initiating this BGP session? It's your application that's initiating, right? When I'm browsing google.com, so internally what happens, it will go to the HTTP. So let's say when I have internet browser, when I type something called http google.com, so my traffic will be taken with the help of HTTP, which is by default resolving on port number 80. Now this port number 80 is a part of TCP, and then this will build a session. They will go via transport layer. They will have their network address header added up with source and destination. It will then go towards the MAC address and so on, right? So BGP is actually initiated in the application layer. So that's the reason BGP is also called as application layer. Okay, so you cannot say BGP is a layer 3 only because of the other factor, like BGP works on TCP. Now TCP is a layer 4, right? So the best way to define BGP would be BGP is called as application protocol. Also, Also, BGP is a layer 4 protocol which sits on the top of TCP. Okay, so when we do the lab, we will see this behavior, how BGP build the neighborship. So as of now, just remember BGP, before becoming neighbors, BGP first build the three-way handshake over TCP. Okay, and then the neighborship will be formed. So that's why we call it as BGP as a uh, TCP protocol. But who initiates BGP? It's your application layer that initiates the BGP session. So we can also call it as a application protocol. How do BGP work? Say for example, in my LAN enterprise, when I have couple of users, okay, let's say I have a HR VLAN, I have sales guys, I have security guys. Okay, now these two team must take router 1 which connects to AT&T. Now let's say these people, the other group of people that should take R2, and they should take the other path. Let's say they must take the Verizon path, right? Now how can I achieve this? With the help of policies. Okay, so BGP is also called as policy based routing. So depending upon my policy, I can play around with my packet that's going toward ISP. Similar thing I can do while receiving the packet. Okay, while receiving the packet, I can say that I don't need from AT&T, instead it comes to R2. Okay, so we can play around with the traffic manipulation. So it's a policy based routing protocol. BGP is AS dynamic routing protocol. Now what is AS by AS? It's nothing but autonomous system. Okay, why do we say BGP as autonomous system? So let's say I have one LAN segment, this is my core router, and I have ISP over here. Okay, now this whole topology will be part of one autonomous system, and this will be part of another autonomous system. So who provides us autonomous system? How do we define these autonomous system? Will be covered up in the next few slides. Okay, but just understand BGP is a dynamic routing protocol between two different AS path or different AS. Okay, so between two different autonomous system, we configure BGP. It's a path vector routing protocol. So if you remember, we discussed initially about distance. We had link state vector, and now we are talking about path vector. So in this case, we manually define our neighbors. So path vector means list of AS on path to destination. Okay. So let's say I have a LAN segment. This is my core router which connects to the first ISP. Now this ISP will connect to other ISP, AS2. Now this connects to another ISP, and then finally they reach to the destination. So what is BGP doing? So basically I am manually defining my neighbors. So the ISP engineers will manually define the neighbors from AS1 to AS2, and this all works on manual assignment. Okay, in the case of BGP, it's manual assignment. It's not a automatic neighbor forming or something like that. It's a manual defining. So that's why we are defining from source. Let's say this is source to destination, right? So we are defining the list of autonomous system on path to destination. That forms a path vector. We are defining the path. On which protocol is this running? It's running on 179, and it's a transmission control protocol. Okay, so the transport layer, which is a layer 4, has two protocol. One is TCP and one is UDP. Okay, so the features of TCP is they are reliable, they support end to end delivery. Okay, they also have feature of sending receipts, or also I can call it as acknowledgement. TCP are slower, okay, because they first have the three-way handshake. What is three-way handshake? So let's say I have a source, I have a destination, okay. So one packet which is called as uh, SYN packet, okay. So a SYN packet is sent from source to destination with some sequence number. Let's say x equals to 1. Now destination is going to reply back with acknowledgement. Okay. Now what is it going to do? It's going to send a acknowledgement and it is going to increment this by one value. Now source replies back with acknowledge. Okay. But so now this has a new sequence with y equals to 1 plus 1. So this is called as three-way handshake. They are finding out if they have a reliable path, there is no congestion in the network, and they have formed three-way handshake, and now the actual data will be passed. In this case, what is the data? It's nothing but your BGP packet. It can be your BGP hello packet, it can be your BGP keep alive packet, it could be anything. To send these kind of packet, first BGP has to undergo via these three-way handshake process. Only then BGP will start its sending its packet. It could be hello packet or a data packet or a keep alive packet. So this doesn't end. Okay, this was very simple example or scenario I explained in the case of three-way handshake. Apart from these normal process of SYN, ACK and ACK, there will be multiple things happening in the case of TCP. Your concepts like windowing, okay, the concepts of sliding, the concept of MSS. There will be a lot of things happening behind uh, this three-way handshake. So basically, why it is done? So let's say I have a source of very large packet size, like 9600 bytes of packet size, and on the receiving side or on the destination side, I only support this many of packet. And intermediately, let's say I have multiple switches, I have routers where might be the MTU or the link between them are of a lower side. Let's say they support only 1500 bytes of MTU. Now you cannot send this whole packet in one uh, what do you say, in one straight point. You cannot send them, right? So you have to first bring up the windowing feature to see, to check what is the best uh, packet size you can send it at a time. Okay, so basically this whole packet of 96 byte will be divided into smaller chunks. So let's say this was totally 9600 bytes. Now you will divide them. This is a process of like fragmentation or segmentation, where you're dividing the whole packets into smaller size. Now this small size packet will be added up with the TCP header, where you will add the sequence number and lot of other things. Okay, so basically they are now finding out what is the windowing size, what is the sliding, and what is the MSL. And later on, when the TCP packets are sent, now they will send accordingly. One packet will go with the headers, the next will go, and once all of them receives on the destination side, because of the sequence number, they will re-segment. Okay, the first one comes on the first way, the second comes to second, and so on. Now let's say if one of them was lost during transmission. Now this receiver side is gonna inform that I have lost one of the packet. So you resend me that. Now this person has to resend that. Okay. If it doesn't resend, so this whole thing will be dropped. And now this source has to resend again from scratch. So that is why TCP are called as reliable, and it is slower when compared with your UDP. In case of UDP, there is nothing such things happening. It will send the packet. If it receives on the destination side, it's well and good. If it is dropped, or let's say one or two portion of the packets are dropped, so that's your loss. Okay, so that is why, like, video streaming and all these uh, kind of medias are used over on UDP, where we need faster, but at the same time we cannot achieve the complete 100% packet transfer. But in the case of BGP, I cannot compromise. I cannot see my packets getting dropped, because they are coming from various LAN segment from the users, right? If the packets get dropped, so basically there will be a lot of instability in the network, right? So that is why this BGP act as a reliable protocol, and because of TCP, the behavior of a TCP is achieved inside BGP. Okay, so it's an open standard routing protocol. That means multi-vendor supportive, scalability, reliability, which we checked. It's mainly to control, not for the speed. That's what I said. If you want speed, you see it in case of the LAN protocols like OSPF, EIGRP, RIP. Whereas BGP is not meant for speed, it's meant for reliability and for controlling the internet. Okay, BGP prevents loop using AS number. Now every protocol has their own mechanism. In case of EIGRP, it had a mechanism called as split horizon. Okay, in case of OSPF, there was no looping because they are a link state vector. That means inside their database, okay, they're gonna have information of all the links. So basically there is no chance of having loop. Now in the case of BGP, how is loop avoided? So there are two flavors of BGP. One is called IBGP and eBGP. So we will see individually, but as of now, from loop prevention, I'm just telling you. So in the case of BGP, there are two flavor: IBGP, eBGP. IBGP will have two ways to remove the looping. One is called as full mesh, and other one is called route reflector. Whereas in eBGP, we have AS number getting added up with every packet. So that is what this point says. It prevents loop using AS number. Now what is that? So it means, let's say I have one LAN, LAN number 1, and on other side I have LAN number 2. Now this is connecting to ISP 1, ISP 2, ISP 3, and it finally arrives to this. Okay, so what this line says is, when I am routing a packet, or when I'm sending a packet to the ISP1, so that ISP1 is going to get tagged with my traffic. So let's say I'm sending 1.1.1.1. Now that arrives over here, 1.1.1. Now that packets, that route or that network is received here. Now this AS number is getting added up, or it's getting tagged up. Now that goes over here, 1.1.1.1. Now it has AS number 1, AS number 2 is getting tagged, and then it arrives to the destination. The reason this AS tagging is done is, let's say for some reason the packet was rerouted back to AS1. Now once the packet arrives to this AS, there can be looping, right? Your packet which is going in one direction, now due to the faulty routing, let's say the routing on your ISP3 was pointing back to ISP1. Now the packet will be in a looping condition, but that doesn't happen in case of eBGP, or that doesn't happen because I'm tagging my autonomous system number. As soon as my packet comes back with 1.1.1, 1 added up, 2 added up, 3 added up, now it's receiving over here. Now this autonomous number will see that I am my autonomous system tagging is already present on this network. So how can I route this further? So it's going to drop it. or it's going to discard it. So there will be no looping happening. Okay, so that is what this point number says about looping. Regarding the IBGP, I'll tell you the full mesh and route reflector, how it works and what are the components. But as of now, just understand BGP has a looping avoiding mechanism. Okay, so BGP will support fixed length subnetting mask, variable subnetting mask, and classless inter-domain routing. So they are gonna support the one which OSPF was also supporting. So something very similar to OSPF characteristic. So regarding summarization, it will support both auto and manual. So manual is when I okay, so this is a summarization when I can define, and auto is by default it's going to consider it. So basically when I'm writing my BGP process, I usually go with no auto summary. I don't want my router BGP to automatically summarize, so I have to turn it off. By default auto will be enabled, so I am going to turn that off. Manual is when, let's say, I want to summarize, and uh, I just want to define the summarization on my own way, so I can bring up the manual summarization. BGP updates are incremental and triggered, so there will be BGP incremental packets and triggered packets that will be sent across. There will be no periodic updates. Okay, BGP updates are sent as unicast to manually defined neighbors. So that means, let's say I have my LAN number 1 and I have a ISP and I am running BGP between this BGP session between this. So basically they are one to one, or they are manually defined neighbors, right? So I can make use of unicast packet, that is one to one packet. Whereas in the case of OSPF, how were the hello packets or how were the update packet exchanged? It was exchanged on multicast uh, communication mode over on 2240.0.5 in case of OSPF, because the neighbors are not predefined or not manually defined. They form their algorithm, the SPF algorithm, and they form the calculate the shortest path to reach the destination. Okay, so the things are auto I can say. Whereas in BGP, I manually define so and so is my neighbor, so it's unicast in nature. Administrative distance is 20 for external, and BGP administrative is 200. That is when you have eBGP, external BGP, where you have 20, and when you have IBGP, it's gonna be 200. The reason is, in case of eBGP, the neighbors are manually configured. So when I'm manually configuring my neighbor, so it's more reliable, or I can say it's more trustworthy. I know I'm doing my configuration in a right way. But in the case of IBGP, the neighbors are not required to be connected face to face. Okay, so in the case of IBGP, they don't need to be directly connected. They might be in this order, right? Now this and this are not directly connected. So in such scenario, any route, let's say you're learning a route 4.4.4.4 over on R1, now those will have the AD value of 200. Okay, so that's the difference between IBGP and eBGP. In the case of eBGP, you're seeing very good AD value, so the lower AD value is preferable. You see lower value in case of eBGP, even though they are between two different companies or two different autonomous system, a better value, because we are manually configuring our neighbor. Whereas in IBGP, I do not configure anything manually. They will auto discover, like how we have in case of OSPF. Okay, So I don't define it. I don't define manually. They don't have to be connected manually, point to point. They don't have to be like connected point to point. So that's why they are not trustworthy. Might be if I have some other protocol like OSPF running here, the OSPF will have a better route of 110. So that will be taken up, or that will be preferred when having BGP in your network. Okay. Regarding load balancing, BGP is not a load balancing protocol. There will be no equal load balancing, neither non-equal load balancing in the case of BGP. Okay. So when you see the BGP routing table, you will see one destination is gonna have only one best path. There will be nothing like 1.1.1.1 can take either 192.168 1.1, or also it can take 192.168.2 because they have the equal cost on AD, right? In the case of OSPF, we had checked a destination can have two best path depending upon the equal cost. But in the case of BGP, they are not gonna have load balancing. Okay, the reason is they will only support one path, not more than one path. Okay, as I told, there are two flavors. So when do we call IBGP? So let's say I have, okay, so let me show you the real topology. So let's say I have this network topology. So when I configure BGP over here, I call it as IBGP. Okay, internal border gateway. So between two known routers, two Vodafone known routers. The reason is they will have the equal autonomous number while configuring. But in the case of AT&T and Vodafone, if I have a BGP running here, now the autonomous will be different for Vodafone. Similar way, from Vodafone point of view, the AS value is different. So if you see, this is 65,000 and this is 65,001. So they are different autonomous systems. So we call it as EBGP, External Border Gateway Protocol. Okay, so what else? The neighborship relation for EBGP and IBGP are slightly different. So we will talk about that while doing lab. IBGP neighbors no need to be connected directly. That is what we discussed, and that is the reason the AD value is so high in the case of IBGP. It's 200. Whereas in the case of EBGP, they have to be connected directly, something like neighbors. So they have a better trustful features, like the AD is better. BGP guarantees loop free routing. So both IBGP and EBGP have their own mechanism to fight against looping. Okay, so we will also discuss that. BGP has no auto discovery mechanism, so that has to be manually set. Okay, there is no auto discovery in the case of OSPF and EIGRP. We could just configure these protocols and they would have auto discovered their neighbors, right? But in the case of BGP, I have to manually define. BGP protocol is used to exchange internet routes. BGP protocol is a layer 4 protocol that sits on the top of TCP. Okay, so the key points are discussed. So let's check it out. Okay, so let's check it out why BGP is called as application. So basically, BGP is called as application or layer 7 protocol. It's serving the purpose of layer 3, that is sending the IP address. IP address is a part of layer 3. It's exchanging the layer 3 networks. It's forwarding the layer 3 protocols, right? But BGP relies or depends on TCP or a layer 4 protocol. Okay, BGP will not initiate until this has taken care of. So that's why we call it as layer 4. And at the same time, who initiates BGP? It's your application who will initiate the BGP session, right? And that's why it's called as application or layer 7 protocol. Okay, so that was a brief on BGP. Okay, now there were few keywords that we were bringing up frequently, like autonomous system, autonomous system numbers. Okay, so we need to understand what exactly are these. This is very important in case of BGP. The whole BGP lies over on AS and AS numbers. Okay, so who gives us these autonomous system numbers? So let's say I have a company XYZ and I need a internet service, or let's say I have users who wants to connect to internet, or who wants to browse to an site B or a branch B office. Okay, so I first need to take ISP connection. Okay, ISP1 connection. So who is going to give me all the details like autonomous system? So let's say the ISP are running on autonomous system 65001. Now who is going to give my autonomous system? So these are given by the online entity called as INA. The entity which also gives IP address, port numbers. So this is the same entity which also gives AS number. Okay, now these AS numbers, or the AS number, are of two types. One is called as private, other one is called as public. Okay, now previously AS number, or autonomous system number, used to be 2 bytes. Why were they 2 bytes? Because of IPv4 protocols, or IPv4 uh, capable 2 bytes. Now due to IPv6, this is falling on shorthand. Okay, we cannot make use of 2 bytes, so we have the latest ASN which comes with 4 bytes. Now 4 bytes also have two flavors, that is private and public. Okay, so we will see all these things in next few slides. So that was just an overview. Okay, so what is ASN? ASN is nothing but organization require connectivity to internet must obtain the AS number. So I have written obtain because I have to request for the ASN number. It's not that I configure BGP and automatically I will get these autonomous system from my router or something like that. I have to get that autonomous system. Okay, so how are these ASN number look like, or how do these ASN number look like? So let me roughly tell you the range of ASN, the legacy ASN is 0 to 65535. Okay, now this is a 2 bytes of data, or 2 bytes of AS value. Okay, so they used to be 2 bytes. Now what is 1 byte? 1 byte equals to 8 bit, and 2 byte are going to be 16 bit. What is the size of IPv4 address? It's a 32 bit. What is the size of IPv6? It's 128 bit. What is the size of a MAC address? It's a 48 bit. Okay, so in the case of ASN value, if you just make it 32, so that's going to be these values. Okay, it's going to be pretty high value. Now the 2 bytes cannot hold the complete requirement, because 2 byte is going to just support 65,000 only. Okay, and since we have IPv6 coming up, so we wanted a better, or a advanced solution for this. So due to the exhaust, so RFC, the new RFC was defined for 4893 to expand the ASN field. Okay, to accumulate the 4 bytes. Now 4 byte is nothing but 4 into 8, which is 32 bit range. So that is why 4 bytes of ASN value was launched uh, to accumulate, or to match the IPv6, or or with the expansion rate, we wanted a higher byte value, or a advanced ASN value. Okay, now this 4 bytes can support so many ASN values or ASN numbers. Okay, so what was initially it supporting? It was only supporting 65,535, but after the advancement of ASN to 4 bytes, now this many ASN values can be supported. Okay, so this was regards to ASN, which is autonomous system number. But what is autonomous system? Autonomous system is a group of IP network operated by one or more network operator that has a single and a clearly defined external routing protocol. Exterior routing protocol are used to exchange routing information between autonomous system. Okay, so what is autonomous system? Let's see that. So for that, I have this diagram. So let's say this is ISP1, which has AS value of 100. Now, what do I see within this? I will see multiple routers following a single policy, following a single routing protocol. Might be they are running OSPF or they are running EIGRP, right? And who is managing that? It's your who is administrating that. So there will be one administrator who will be administrating this, right? So it's nothing but AS is nothing but it's a group of IP networks. So there can be multiple networks which is operated by one or more network operators. So it can have one operator, it is connected to another ISP. Okay, how are the policies set? So they will have their own policy. So this policy is uh, limited to these autonomous system. Similar way, I have one more autonomous system where I have two routers. Now I will have their own policies, I will have their own routing protocols, I will have their own IP networks within this AS number. Okay, so this forms an AS number. Now similar way, let's say I have my company XYZ. Okay, this is a core router. So the core router along with the distribution and all whole over things. Okay, so I'll be provided or I'll be given a AS value. So let's say my AS value is now 6500. So this is my AS value going to be, and I'm going to connect to other ISP who has a AS value of 65001, and that ISP is connecting to another ISP which is having 65002. Now these AS values are very important in the case of BGP. Okay, there is no way uh, I can avoid looping, right? If there was no concept of AS, probably I would have lot of looping scenarios. Why? Because let's say on this AS value, I have couple of networks like 172 network, 192. Now there is a chances that these network are also seen across here, 172, 192. But what is it making it uh, differentiated? Let's say this network and this network, how are they differentiated? It's because of the AS value. These networks are part of this AS value, because every traffic is going to get tagged with the AS value. Similar with these network will tag with their own AS value. So that is why AS value in case of BGP is very important, because they are the sole point for avoiding the loops. Okay, otherwise internet would have filled with multiple loopings, because everyone or anyone can have any set of IPs. There is no restriction that XYZ company cannot make use of 172 or they cannot make use of so and so, right? They are free to use anything. It's your AS value which will differentiate your packet. Okay, so that was regards to autonomous system. Okay, now these are few couple of paragraphs that's about how you get the AS values. Okay, so AS values are given by INA. So basically what happens is INA, which is also called as Internet Assigned Number Authority, they give blocks of AS value to RIR. Who is RIR? RIR is your regional internet registries. Now this RIR have multiple regions. So let's say I have Asia Pacific, I have Europe, I have Latin America, I have Africa, right? So basis on regions, they are gonna give the blocks. So INA, basically what INA is going to do, INA is going to give the blocks of AS. Okay, so let's say I have from 0 to 65535. Now what INA is going to do is, INA is going to create a block. So let's say it's going to create a block of 35,000 to 3500. Now this has to be given to Asia Pacific. Now the next block is, let's say, 3600 to 3650. Now this will go to, let's say, Latin America. Okay, so basis on the blocks and basis of the region, the ASN will be given to us. Let's say if I apply for an internet connection, okay, if I am applying for an internet connection from AT&T, so they are going to give me all the details that you are gonna have so and so AS value, and this is the public IP that we are giving to you. Now who gave these AT&T these AS value? Is this online entity who keeps record of every individual AS value. So we will check this. Okay, I'll show you how does these blocks look like. So these are block assignment by INA. So entity wishing to receive, so basically if a company wants to apply for internet connection, or they want to get a ASN, so they must complete the application process of their regional internet registries or local internet registries, your local internet services, right? Like in India we have a lot of local entries like ACT, may not be you guys knowing. So in India there are many local internet registries, while also we have some regional internet registries which who have a cable beneath the sea, or the submarine cables, okay, like Tata or cable and wireless. So there are a lot of companies which have underneath cable. There are some regional internet registries as well who pay these providers, and then they sell the internet for some region or for some package or something. Okay, so basically you have to apply your application, and these are the service provider, then they will provide you the ASN values. Okay, so we can see we can see these ASN assignment on the website online. Okay, so that is why I have mentioned these websites. So this is the main website where I will show you the ASN values. Okay, so as I told you, these are RIR, regional internet registries. Okay, so based on regions, the INA are going to give blocks of ASN value. So let's say I have Africa region or Asia Pacific, I have Canada, US, okay, I have Latin America, I have Europe, right? So there are multiple regional entries. So if I open them, so this is for Africa, this is for Asia Pacific. Okay, so if I go to Asia Pacific, and so I can apply for ASN value. Okay, or to get the ASN number. So it says get IP address, transfer IP address. Okay, go IPv6. So when do we need IP addresses, or transfer IP address? It's when, let's say, I had a company XYZ which had a internet connection from some local internet registries. Okay, and now I'm moving on from those local to a regional internet entries. Now in that case, I have to close my previous ASN and reapply for a new for a latest one. Okay, so these are few things which happens in the back end. Might be you may not be aware of all those things, like how ASN or how is these things happening. So let me show you the block assignment. Okay, so if you see here, they are divided into couple of blocks. Okay, so what is the ASN range? It is from 0 to 65535, right? Till here. But to but since this was exhausted, we have introduced advanced ASN of 4 bytes, which can support up to this value. Okay, that is why you see two different tables. So the first table is starting from 0, which is 16 bits, 0 to 6535, and if you observe, they are in a block structure. So assigned by AppNic, assigned by this regional services. Okay, so they are in a block given to this AppNic. And now these people, these service provider, when I approach them, when I say I am a startup company, I need a internet connection, I want to connect to internet, I have to fill some documents, some paperwork, and then they are going to assign me one of the ASN value. Now once I get this ASN value, if I want to transfer or if I want to take another internet connection, there are couple of rules to be followed. Okay, so I have also mentioned them, like what are the rules and what is the frequently asked questions. Okay, so when should AS be created? It's created when your network wants to connect to internet. Okay, so let's say you have a company XYZ, you don't need any internet connection, so that means you don't need to apply for any autonomous numbers. Okay, but let's say you have users and they want to connect to another branch office. Now this happens over on internet. Now there comes a need for AS registration. Okay, or let's say you need internet connectivity, you have extensive work going on with Google, or you always have your users who are dependent on Google services. So in that case, you need internet and you need to have AS registration. Okay, if there is no requirement of internet, you don't have to uh, process paperwork. If you need network or connection between one or two AS, then yes, you have to need AS value. Okay, when is a public AS number required? As I told you, the ASN are of two type. One is private and one is public. So why do you think we need private and public? Okay, so it's when I have my, let's say I have my company XYZ and it's connecting to just a single ISP. Okay, so in this case I can go with private ASN value. Okay, so there are certain private ASN values. There's some group or a range which I can use for private. Now public is used when this ISP is connecting to another ISP and so on. Now what happens is my AS value gets tagged with every ISP and go so on. So in this scenario, when the tagging is happening and my uh, networks are going one ISP to other ISP, that is where I need the public ASN value. Okay, so when is public ASN value required? It's required when AS is exchanging routing information with other AS on public internet. Okay, that is all route originating from AS is visible on the internet. So basically when you have multiple AS, you need public. If you are just with one ISP and there is no other ISP involvement, you can go with private ASN value also. Is my organization eligible for public AS value? So it depends. Okay, your organization is eligible if it is multi-homed, it has need to interconnect with another AS value. What is multi-homed? Multi-homed is a scenario when you have a router with two internet connection. Let's say ISP1 and ISP2. Now this called as a multi-home. It can also be, let's say, two routers, this connecting to ISP1 and then this connecting to ISP2. So that's again multi-home. Okay. So in such scenario, yes, you need public ASN. You cannot go with private. What is the second eligibility factor? When multiple interconnection happens. So let's say I have multiple ISP. So in this case also I need to have public AS value. Okay. That is something which I also told you in the previous point. When can I use private AS? A private AS should be used if AS is only required to communicate via BGP with single provider. When you have only single ISP provider and you need a BGP. In this scenario, yes, you can go with private. Okay. So private have their own block in case of 16-bit or in case of the 2 bytes ASN. So this is the block. This is the block which is completely dedicated for private purpose only. Okay. Similar way, the 4 byte ASN has this block size, around so many ASN value, which is dedicated for private use only. I plan to change my upstream provider. That means I plan to change my internet provider. Can I take my AS number with me? That means still can I take my AS value with my second ISP or so on. Now there is a condition for that. Okay. Let's say if you're going on RIR level, regional internet registries level, okay, the main providers. So if they are providing you ASN value numbers, now yes, you can change ISP to ISP, keeping the same ASN value. Nothing is going to harm you. It's portable. Okay, they are portable. You can just transfer from one internet provider to another internet provider. The issue arises when you have with LIR, local internet registry, and you want to upgrade to RIR. Now these ASN value cannot be used with these. So you have to return this back to them and then apply for a fresh one and then reconfigure your routers for the updated ASN numbers. Okay. So that was a little bit on ASN numbers. Come back and let's see what is the two flavors of ASN, what are the blocks, what are the ranges. Okay. So as you all know, the ASN number, they are of two types. One is called public and private. Okay. So we see these two on 2 bytes as well as on 4 bytes. Okay. And this is the complete chart for justifying the whole ranges. So if you see this, this is 2 bytes ASN, and you can say collectively is 4 bytes. Okay, from 0 to 65535 and till this value, they are going to be 4 bytes. Okay, that's nothing but 2 to the power 32. Now there can be interoperability issues, right? What is interoperability issues? Or I can also call it as backward uh, compatibility, right? Let's say I have on one router 4 bytes of ASN value, and on other side I have 2 bytes of ASN value. So how are they going to work? Or are they going to work or they are not going to work? So in the case of 4 byte and 2 byte, they are a backward compatible. The reason is these 2 byte can be written in 4 byte structure or in the format of 4 bytes. So we'll discuss how do we write that. Okay. So basically there are a couple of more things here. So don't worry, we'll go step by step. So this is about the table, about the ranges of 2 bytes and 4 bytes. Okay. Now what is a private and public in this case? So let's say the ASN number 0 is considered to be reserved. Similar way, you will see multiple reserved blocks. Not this. This is a private use. So in the case of 2 byte, that's a private. In the case of 4 byte, this is acting as a reserve for private use. Okay, I'm talking about different reserve, that is this. So this reserve you neither can use for private or public. Okay, so I can say no private, no public. Similar way, these one, this is not for private or public. Similar way, this is not for private and public. Similar way, this is not for private and public. Okay, so where is public now? So this is public 2 byte, this is public 4 byte. Okay, so the whole thing, the whole block is over here. Okay, let's go to next topic. This is something we discussed. Okay, little more about 4 bytes. Okay, and yes, this is a part of your syllabus. I guess it's a part of NRC. So NRC, it says that one of the topic is 4 byte AS. Okay, so little bit more on 4 bytes. It's not very difficult or very tough. Okay, so let me just quickly go through this. So how do we calculate 4 byte? So basically 4 byte ASN, how do you calculate? It's 2 to the power 32, which gives you this as the end number. Okay, starting from 0 till this number. What about 2 bytes? It was this was the range 0 to 65535. This is going to interoperable between autonomous system 2 and 4. Now that's something which we need to see how is they going to be backward compatible. Okay, the reason is your 4 byte is going to map over on 2 bytes, something like, let's say this was 2 byte. Now with the help of 4 byte I can map even the 2 bytes. Now whole thing is a part of 4 byte. So that's why they form a backward compatible. Okay, and we call it as mappable ASN. Mappable is nothing but we can take over on the 2 bytes. So the values of 2 bytes, let's say 65535, 65534, 65533. So these values we can write in the format of 4 bytes. Okay, now that's interesting thing. I will show you how do we write that, or how can we convert from 2 to 4 bytes. So make use of this website. Okay, so what are the two bytes AS value? The last number of 2 bytes is 65535. If I convert, so I can see they are getting converted to this values. Okay, they're getting added up with 0 dot, and then we can see the decimal format. Let's see the value for 0. Okay, it says please enter an AS value, because 0 was not a valid range. So what about 1? So they are going to be 0.1. What about 2? AS value 2, that's going to be 0.2. What about 100? So they are going to be dot 1. Okay, so what about 65535, the last AS value of 2 bytes? That's going to be this range. Now what about the next value, which is a starting ASN for 4 bytes, right? So let's say 2 bytes, it's 0 till 65535, and from 65536 is where your 4 bytes will start. So basically, hold together, you call it as 4 bytes. Okay, but this is the number from where your 2 byte ends, and you have the continuity, right? So what is that's going to resolve to? So let's check it out that. Okay, so that's going to be 1.0. Now what is the next ASN value going to be? 37. It's going to be 1.1. So now you see, as soon as you enter 4 bytes, you start adding 1 dot. You were in a 2 bytes, you were adding 0 dot, and when now you are in a 4 byte, you started adding up 1 dot. Okay, so we call it as so I'll tell you what is happening. Okay, so let me see some higher values. Okay, like 65 535, something this. Okay, so you can see the converted ASN. Now what is the highest range? So let's try to convert that. Okay, so highest was this, right? I'll copy this. Let me check it out for this. So if you see now, the values, the last value of 4 byte is going to look like this. Okay, so if I write in a 4 byte structure, it started with this, and the last it ends at this one. Okay, so you have your 2 bytes till some point like 6535, and then you have your continuity of your 4 bytes, and this is the notation. This approach is done to have the backward compatibility. Otherwise, those AS value which are running on 2 bytes, and now you have a 4 byte, now they can have some issues, right? So this is how we solve such scenarios. Okay, now let's go to the theoretical topics. Okay, how are these represented? So these 4 byte of ASN have 3 ways of representing. The first one is called as AS plane. Now that's nothing but you just define it in the decimal format like 0, 1, 2, 6, 5, 5, 3, 5, and the last value 4, 2, 9, 4, and some strange weird number which is nothing but 2 to the power 32. But it's very difficult to remember such number, right? So it's little bit difficult to understand or to remember. Okay, AS plane. The second one is called as AS dot plus. AS dot plus. Now what is AS dot plus? That's for something which we converted and we just proved how it works. Okay, this notation is called as AS dot plus. Okay, so what happens is it has two values now. One is called as low order and the other one is called as high order. Okay, so it has a low order, high order separated by a dot value. Okay, the rest are all the theory which you can go through. And then the third way is AS dot. So it's a mixture of first one and second one. If there is any 2 byte range, it is written in AS plane. Okay, and any ASN above that range is written in the dot format. Okay, so let's say if there is a 2 byte, then it will be represented in a decimal format itself or whatever it's. If it is a 4 byte, then it will automatically convert to the AS dot plus, which is nothing but the conversion, the low order and high order. Okay, so these are the three ways of ASN representation: AS plane, AS dot, and AS dot plus, and AS dot. Okay, regarding the allocations, how do we get this ASN values? And let's say if I'm applying in the year 2020. So what I'm going to get, whether I'm going to get a 4 byte of ASN or a 2 byte of ASN. That's something which we'll check it now. Okay. So what are the 5 regional internet and registries? It's these 5: Africa, Asia Pacific, you have America, Latin America, and Europe. Okay, the 4 regional entities. How are they going to give these 4 bytes? So let's say the ASN, which was introduced for the first time in the year 2007. Okay, so during those time, by default, these regional entities used to give 2 byte of ASN. But if someone requested for 4 byte, then yes, the RIR used to offer 4 bytes. Okay, so let me reframe. So let's say 27 was when 4 byte ASN was introduced for the first time. So any company who approached RIR for a new ASN value, so they by default used to give 2 bytes. Okay. Now if those company requested for 4 byte, yes, then RIR provided that. Okay. Now that got changed in 2009. So in case of 2009, by default they started giving 4 byte, but if you wanted for 2 bytes, you should have asked for it. Okay, you should have asked for it. And now it was in your 2010 when you introduced the concept of as dot plus plus, sorry, as plus. So later on they started only with 4 bytes. Okay, because the 2 byte were already exhausted, and since we had backward compatibility, it wasn't a issue providing the 2 bytes or 4 bytes, because they were after all backward compatible. Okay, so let's say if an ISP in the year 19, or let's say in like 2007, okay, ISP called level 3 had offered AS value of 3356. Now what happens to that, or what how does this look like for someone who has a who has applied in the year 2010? So basically this will be getting converted into 0.3356 in the AS dot plus format. Okay, so that is what is about the allocation. So in 2007 it was 2 byte, in 2009 it started with 4, in 2010 it was only 4 byte, and since we had the backward compatibility issue fixed, so we went with 4 bytes only. Okay, so that was a quick intro about BGP ASN values, AS values. Okay, so I have couple of the operation topics for BGP, which is called as peering state and BGP packets. So to prove this topic, I'll straight away do the lab and we can check it over on the lab itself. Okay, so for the lab I have this topology. So let me go to the lab. Okay, I'll just turn them off so that I can reconfigure. So let me start. Let's take the console. Okay, so let's start one by one. So let's say on the first router R26, I'm going to give a host name. So let's call it as AT&T R26. Okay, so it's a AT&T router 26. Let's assign IP address on 0/2. Its IP address is over here, and it's on a /30 subnet. Okay, 255.255.255.252, and no shutdown. I'll go to the second router and I'll name it as Vodafone R27, interface E0/2, IP address 209.165.201.2 no shut. I'll go to the next interface, that is 0/1. I'll say IP address 10.172.13.1. It's a /24, so this would be the subnet mask, no shut. I'll go to the third router, which is Vodafone router 28. So I say host name Vodafone R28, interface E0/1, IP address 10.172.13.2.255.255.255.0, no shutdown. Okay, so now I need to enable BGP process. So as we discussed, between two different ISPs, we have BGP. We call it as eBGP, and the neighbors must be directly connected, or they should be a neighbor. So my first thing would be to see the ping test. Okay, so let's see if I have ping test availability with my Vodafone router, Vodafone R27 router, 209.165.201.2. Okay, so they have reachability. So that means I can configure BGP now. I can also bring up the Wireshark to see the three-way handshake and all other initial process. Let's keep it here. And I can also bring up the debugs. Okay, so debugs can show me the packets types. It will show me the states that it goes over from down to the proper state. Okay, so what is the command? Debug IP BGP events. Okay, and on other side I can also configure debug IP BGP IP v4 unicast. So as we discussed, they are gonna be in the case of external BGP, what is the packet? It's going to be unicast because they are one-to-one connected, right? So I'm going to enable unicast on one side, and on other side I'm going to configure the normal BGP event packets. So let's bring up BGP. Okay, as of now there is no BGP process, so we can also check it over here. So there will be no BGP packets now. So they are as good as in downstate. So where is my PDF? Okay, so basically they are in a downstate. Now let me bring up one of the process. So let's say router BGP, and now it's asking me for the autonomous system. So if you see, this is in the decimal format and this is in the AS dot plus format. This is in AS plain and this is in AS dot plus. So I'll go with the AS that is defined in my topology. Okay, so this is my AS value. So this is my AS value. So as soon as I enable, I can see some packets. Do I see some packets here? Okay, so as of now there is no hello packets. There is nothing, no hello packets. In the case of BGP, we call it as open packet, which will carry the information of ASN value, router ID, and hold timer. In the case of OSPF, we called it as hello. In case of BGP, we call it as open packet. Okay, so as of now there is no open packet, but yes, let's define them. Okay, So what is my neighbor here? So who is my neighbor? So my neighbor is this IP on 2.0.2. So he is my neighbor. On which AS value is he located? He is located on this AS value. Okay. So I defined my unicast. Now let's see what happens. So BGP process getting initiated. Okay. On this side there is no packet being received because we don't have any BGP process enabled. So let's enable over on this side. So I go and say router BGP. Now what is the BGP AS value of its own? So this is the value. What is the neighbor now? So it says BGP selected new router ID. It selected a new router ID. Okay. And now what is the neighbor? Neighbor is nothing but this dot one remote AS. What is the AS? 65,000. So let's see what happens now. So they are gonna carry the open packet, all those things. Okay, now you see a lot of things over here. Okay, and probably the neighbor should come up. So let's see what happens. So you can see BGP adjacency have been come up. So let's go to the first router and let's see the BGP neighbor. So show BGP summary. So it says that it has already built a neighborship with the second router. On second router, it's a Vodafone router. Okay, so on Vodafone router, it has already built the neighborship. What has happened in the backend? So let's verify that. So in the backend, I see the open packet was sent. But open packet is sent when you have those three-way handshake and all other things. So I'll take down or take out this BGP filter and I'll go back to my actual packet capture. So let me scroll up. Okay. So if you see here, there were three-way handshake happening. Okay. So you see the SYN packet was sent. There were a SYN acknowledgement. You can see the SYN packet was again being sent. The reset acknowledge, the SYN reset acknowledge, SYN. Okay, so till here it was all the failures. If it was a case of UDP, your data would have been sent, but in case of TCP, they are not going to send any data because they have not formed the three-way handshake. So what happened is it started with SYN packet. It was trying to build the three-way handshake, but from the second uh, router, it wasn't receiving any acknowledge sync. It was sending a reset packet. There could be multiple reasons for sending reset because on the second router, while bringing up BGP process, it started up with negotiating, but it was not acknowledging because I have not have placed the neighborship command, right? So let's say what was my command. So first I went with enabling process. So as soon as I enabled, I saw all this reset happening. Later on, when I defined the neighbor packet, that is this particular line, so you can see there were some delay from that to this line. So that is why you saw some reset. Okay. In the case of reset, so you will see they were sending a reset flag. Okay. So once both the IPs were negotiating, they formed three-way handshake. So you see SYN, SYNAC and acknowledge. Okay. Once after three-way handshake, once the TCP has formed the reliability, it started sending the open message. Now open message is as good as the hello message in OSPF. So OSPF, so hello message is gonna carry lot of information now. So what is it going to carry? So it's going to carry your BGP AS value. It's going to carry the identifier numbers. So that's what I have written here. So when open packet are sent, so it's going to carry a lot of information to form the neighbors between two routers. It's going to carry AS value, the router ID, and hold timer. Okay. So once this has been sent, so once after the neighborships are formed, so let's see what was done. So what happened after that? So you see open packet. Okay, the open message was being sent from dot 2, and then the open message was sent from dot 1. So basically R1 and R2 both started sharing the open message. Once they formed the neighborship, they started sending keep alive. What is keep alive going to do? It's going to see if the neighbor is up or dead. If it is dead, it's going to wait till the default hold timer of 180 seconds, and then it's gonna put it down, it's going to say the neighbors are down, right? So the keep alive is mandatory in the case of routing protocol. So now it's going to send only keep alives, and then it's sent a update message. Now what is update message going to carry? So update message is going to carry all the routing information. Okay, so it's going to carry any new route added up, or any routes that's been deleted, right? Or any path attributes. Now we'll discuss about path attribute in next class. So what is path attribute in BGP? That's something which will be taken care by the update packet. Open packet, update packet, keep alive packet. Now what is notification? Notification is when there is a problem. When there is a problem with your existing network, that is where your notification will be sent. Okay, so let's see what else do we see here. So we see update packets, we see keep alive, update packet, keep alives. Okay, so just keep alive. So nothing else here. So I see TCP packets. Okay, and if I just filter it for BGP, then these are the ones: open packet, keep alive, update. So this is what happens in the very beginning stages. Now there are many factors when BGP neighbors don't form. One common reason is, or one common factor that you need to see is, if you have allowed TCP 179. This is possible when you have access list placed which is blocking this TCP 179. Because if you see, all the communications are happening over on TCP 179. So let me just show you. So if you see this packet, it's on port 179. If you go to the next one, that's on destination 179, back to 179, once again 179. So all the communication are happening on 179. So in case you are being asked in the interview that I have a neighbor, I have two routers and I have configured, and I see the neighborships are not coming up. So what could be the reason? So one reason could be if you have not defined AS value. If you don't have AS value, you will see intermediate fluctuation. Okay, your BGP coming up, BGP going down. That's the case when you uh, have a mismatch of AS. Now the second reason could be when you have disabled 179 by, let's say, access list, or you have some access list on that interface which is also blocking 179. So due to this, there can be issue regards to the neighborship. Okay, what else do we see? So let's see one by one packet. So on, when I see open packet, open message, so I can see the IPv4 header, I can see the TCP header. So TCP header says its source is 179 and this is the destination. So what is this TCP header going to carry? It's going to carry sequence number. It's going to carry the TCP segment length. It's going to carry the flags. It's a acknowledgement. This is the window size that I was talking about. So in the case of TCP, it's gonna support multiple things like windowing, sliding. Okay. So what is windowing? Windowing is nothing but it's setting up a size. Let's say this is a space, okay, between source and destination. So I'm going to set a window size. So let's say this can support 1500. Okay. So that means I cannot send my whole packet of 9600 because the window size is only 1500. So I have negotiated. This was negotiated during three-way handshake. So if I just go back and if I show you the three-way handshake packets, let me go and search for TCP and let's pull up the SYN packet. Okay. So this is my SYN packet. So if I open SYN packet, so they have negotiated for the windowing. So you can see straight away over here. So your three-way packet or the three-way handshake is gonna have multiple components which we normally don't think about. We normally, if someone asks us what is a three-way handshake, we always say it's a uh, SYN ACK and acknowledge. But these packets are also gonna take the windowing size, the MSS size. Okay, so you can also see this windowing size mentioned here and the MSS size. So this values will be later on used while sending up the data packet. Like in case open data packet, they have negotiated for window size. They are sliding, they're pushing the packets. If this packet can go in one stretch, that's fine. If it is not, then it will go part by part. Like let's say I have a whole segment. When do we call it as segment? In the transport layer. Let's say this segment was of 96 bytes. So what happens is I see this whole segment will now be coming or will be sent part by part. So one segment will get added up with TCP header, will go to the network layer. Network layer will add its header. The layer 2 will add its header and then it will send it. So basically they are going to add multiple things like header will add about fragment numbers. It's going to add the destination and source address, whereas the MAC header is going to add the sub layers like MAC address, the LLC logical link layers. Okay. And over on TCP it's going to add the TCP number, it's going to add the windowing, the MSS value, and part by part the one segment goes, the second segment is ready to be pushed, the third will be sent, fourth will be sent, and so on. And on the receiving side they get resegmented, so they have to get resegmented and now the sequence number will be checked. Okay, so let's say this was sequence number with some hexadecimal value, so that is the first sequence, the second sequence, this third sequence. So they are gonna get sequenced once again. So that's how data will be pushed. Okay. So in this case, the whole thing are being taken care by the three-way handshake, and now the data like open message, the keep alive message, they will follow accordingly. So and in the case of data, we can see what is open message going to send. It's going to send the AS values, the hold timers, and the identifiers or the router ID. Okay, that would be better, easier way to say. So what are these things? So these are the datas along with that. Okay, so it's going to say it is supporting 4-octet AS. So a lot of other internal components it's going to discuss on open message. What about in the keep alive? Keep alive is just to see if the neighbor is up or dead. So you can see it's just a keep alive. There is no other information. There is no information of router ID, AS value, right? It's just going to see if it is up or dead. What about in the update message? So in the update message, there is no withdrawn routes. That means there is no route deletion. There is no attribute that we have changed. So basically it is just a blank, going to be blank. Okay, there is nothing much there. Okay, so let me once again take you back to the theoretical topic. So the four messages are open, update, keep alive, notification. We have checked it. What about the peering state? So basically they are in ideal state. They will go to the connect state. Connect state is when the TCP connection initiates. Okay, basically the three-way is getting started. So that's a connect state. Active is when you are trying to establish. Now this is a bad output. Okay, so if you see somewhere this or this, then that means you have a problem. Router is looking for neighbor but it's not forming a neighbor, so you are stuck at ideal, which is a bad example. It's trying to initiate or it's trying to establish, but that it's not happening. Now that's also a bad factors. Okay, so as I told you, there could be reasons like AS mismatch, or you have blocking the TCP 179, due to which there is no neighbor formation. Okay, so connect is when they initiate TCP. Open sent is when they have formed the neighbors and now they are sending the open message to establish the peering. Okay, so so open sent is when the three-way is achieved. Three-way is achieved and now they are sending a open message which is going to carry router ID, attributes, and hold timer to establish neighborship. Open confirm is when they are neighbors and now they are sending keep alive just to make sure that routers are up and running. Establish is a good example. So it's when you have a successful BGP neighborship. So let's check it out on the CLI. Okay, so if I remove the debugs, show IP BGP neighbors, sorry, go with summary, show IP BGP summary. So now you will see couple of things here. Okay, so where can I see that they are established? It's over here on the timers. So they are being established and they have been up since 15 minutes. If I make use of show IP BGP neighbors, I can see BGP state is established. So that means I'm at a good point. Okay, I'm actually have achieved my result. Okay, now regarding to the table, so let me tell you what exactly they are gonna reveal. So let's say when I have the show IP BGP summary table, so basically what does it resembles? So this is going to contain the router ID. So the local router ID. So for a Vodafone 27, this is acting as a router ID. This is the local autonomous system for Vodafone routers. The table version is 1. The main routing table version is 1. This is the neighbor. Neighbor in this case is a AT&T routers. Okay, the neighbor is AT&T. We are running BGP on IPv4. The remote neighbor is on this AS value. These are the packets sent. So now this could be anything. So let's say okay, so there is a command where I can see the packets. Okay, let me try with show IP BGP neighbors. Okay, so now you see here the packets. Okay, so it's gonna say you have sent 1 and received 1, and these are the keep alive which are increasing. Okay, so that is why you see around 22 or 23 packets. See, totally you have so many packet received and so many packet sent. So basically that is a collective figure, okay, which can include open, keep alive, update packets. This is the table version. This is in queue and out queue. If your packet like hello packet or keep alive are stuck, or they are not getting processed, or they are not going out of that interface, then you will see the counters increasing. As of now they are 0. That means there is no queuing happening. Your packets are going in a normal behavior. These are being enabled since for 16 minutes. State or prefix received. So basically state is blank. That means we are good. If in case you would have seen state to be ideal or active, now that would be a bad example. As of now you don't see anything, that means you're good. For a prefix received it says 0. That means I have not advertised any network as of now, because this was just a demonstration. Okay, so I have not advertised any network command. So as of now there is no network that is learned or that is advertised, so there is as good as 0. Okay, so that's a quick lab on BGP. So in the next class we will do lot many things on BGP. Okay, so you guys might be already aware of BGP topics like path attributes, then the troubleshooting on BGPs. Okay, so couple of things which will come up in the next class. So let me know if you have any doubt with respective to the class today. I see 2 messages here. Okay, so this topic FLSM, it's a part of fixed length subnetting mask. Okay, let's say you have /24 network and you want to divide it equally into 30 host, 30 host, 30 host, and like, or 30 host. So might be you're going with equal or a fixed length distribution, whereas the other one is called as VLSM, variable length subnetting mask. And now if you're breaking a whole /24, you can break it into, let's say, for 10 host one block, you can give 50 host in one block, might be you can give another 30 host in another block. Okay, so the wastage is very less in this case, whereas here it's easier to calculate, but there could be some loss. Okay, but practically how does it work? So let's say this 30 host is nothing but it's for a sales team, and by default the strength of sales team were only 5, but due to the FLSM you are wasting like 25 IPs in this case. Similar way you have a security team, so who wanted 35, but the maximum you can go is 30. So what you will do is you will go with the next block also. Okay, or you can say you cannot accumulate the rest of 10 users. Now that's a drawback again, right? So same thing, like let's say you wanted only 2 IPs, but since you're making use of LSM you're wasting up multiple things, whereas in VLSM you need, let's say you need 7 IPs, you can make a block size of 10. You need 40 IPs, you can make a block size of 50. A similar way you need a like 20 IPs, you can make a block size of this. So you need to calculate this. This is purely a CCNA topic, especially under the subnetting topic. So subnet can be done on 2 ways. One is called FLSM and VLSM. So it's just about dividing a broad network into smaller bit. Let's say in my case I have made use of subnetting. Okay, if you see here I'm making use of this /30, right? Now I can still make use of the rest of IPs for some other purpose. See, let's say this was a /24 network, but my ISP gave me 2 IPs because I need only 2 IPs over here. So what happens? I still have multiple free IPs which I can give it to other companies. So let's say I have another company here with uh, let's say Tata. So you can give two IPs out of these public IPs, okay, on 30, another 30. So basically the whole 24 you are dividing into multiple smaller blocks, okay. So that's a subnetting concept. How does one ISP connect to another ISP that is in different countries? So basically you will lay cables, okay. So if you're not sure, again this is something which we talk in CCNA. So let me show you the submarine cables, okay. So if you get time, once go towards this website which is called as submarine cable map, which will answer your question like how two countries are connected. So it's over on optical fibers, okay. So let's say from India, let me just zoom it, and let me take one of the cable. So let me pick one of them, okay. So if you see, we are all connected on this fiber link, okay. So the student who are accessing this Zoom conference, if you fall on any of this neighboring countries or continent, so we are connected over on optical fiber. Now what is this optical fiber called as? So the name of optical fiber is this. What is the optical fiber length? It's 28,000 kilometer. Who is the owner? This is the owner. Where are the landing points? So these are all the landing points, okay. So this is how country by country the ISPs are connected. Now if I just redraw what I was trying to do it in the case of BGP, while telling that this is a LAN 1, I have LAN 2, and now they are connected into multiple ISPs. So basically let me try to show you here. So what I was trying to say is, let's say I have my LAN 1 here. So I am getting the ISP from my own provider, from the provider who is from my own country. That could be Tata or Airtel, Geo, could be anyone. Okay, so these guys are having these guys have the submarine cable. They have invested on the submarine cables. Okay, now the same submarine cable, when it arrives on different country, now these are not going to handle them. So there will be the local or the main RIR who is handling these ISPs. So this ISP forms ISP2. This is ISP1. Similar way, when they go another country, they will be having ISP3, then ISP4, ISP5, ISP6, and finally they reach towards the destination. Okay, so your packet which originated from India went through multiple ISP and then arrived to destination. That's something which I show it in the class, something by in this representation. One LAN, other LAN connected over multiple ISP connections. Okay, so I hope that answers your question. Okay, fine. So any other doubts before we wind up? Okay, so I take it as no, and Monday we will do advanced BGP. Okay, so have a nice day, have a good weekend, and keep practicing. See you soon on Monday. Okay, have a nice day. Take care.